All right, question number 3. It wants us to determine whether Rowley theorem applies to the given function on the interval, and if so, we're going to find the points that are guaranteed to exist by Rowley's theorem. Okay, so we're going from some point A to some point B. We're going to plug in and make sure those two y values are the same. So first thing I want to test to see if f of 0 is equal to f of 7. Alright, so if I plug in f of 0, that's going to give me a 0 for the x times 0 minus 7 squared. We're setting that equal to a 7 times 7 minus 7 squared. It doesn't matter what happens here, 0 times anything is going to give us 0 for that y value, and then 7 minus 7 is 0, so even when I square it, we get 0, and so we get both being 0. So Rowley's theorem is satisfied in the fact that f of a is equal to f of b. Okay, this will be a continuous function, and so now we want to find the point C that gives us a derivative of 0. So we're going to say f prime of x, and let me just multiply this out. Would it help me to do that instead of doing the power rule? I think so. x minus 7 squared. Okay, I'm going to FOIL this out. I'm doing the shortcut. We're going to square, multiply these two and double it and square it. So we are looking at x times x squared, negative 7x, double it, negative 14x squared plus 49. Distribute that x through, x to the third minus 14x squared plus 49x. Okay, we're going to take the derivative using the power rule. Alright, so it's going to give me 3x squared minus 28x, and then plus 49. We're going to set this equal to 0. I cannot factor out the 3. Not all of these are divisible by 3, so we're going to just factor it normal. 3 times 49 will give us 147. And we're going to take the factors of 147 to find numbers that subtract and give us 28. Alright, so just to kind of speed this up, I'm going to use calculator to kind of help us do some heavy lifting. I'm going to go to y equal. This is going to help me get all the factors. I'm going to take the 147 and we're going to say divided by x. This is going to plug in different numbers, 0, 1, 2, 3, 4, and divide 147. If we do second graph to look at the table, it's going to give me all of those numbers. Now normally we start at 0 or 1. And so I'm going to write down the whole number pairs. So 1 and 147. Alright, we should get 3 and 49. That's another one that multiplied. And if we keep going down the list, we see 7 and 21. And I believe that's what we want. We want to add to get 28, and 7 and 21 will give us that. Okay, so I found the numbers that we need. So continuing with the factoring process, 2 sets of parentheses. Now I do a little bit different. So again, the leading coefficient of 3, I don't know where it goes, here or here. So I'm going to put it in both. Again, this is incorrect, but we're going to fix it. So just let yourself know that this is wrong. You can factor by grouping and sort that out, but I like this way. We're going to put the x squared, we're going to separate it and give each one of these an x. The 7 and the 21, we're going to add them to the back. Two numbers we use. In order to get these to add up to be a negative 28, we need them both to be negative. Okay, first sign is your bigger number. 21 is negative. This tells you same or different, and they're the same. All right, so we have it factored. The next thing we do is get rid of what we messed up with. Both of them are not supposed to be 3. 3x times 3x is 9x squared. That's not 3x. So we're going to divide and just drop it off. So can we reduce 3 and 7? We cannot. They're prime to each other. So 3x minus 7. We can divide 3 and 21. Divide by 3, and we're going to get rid of that 3. That's going to be x divided by 3, another 7. So here is our factored form. And from here, we're going to set each factor to 0. 3x minus 7 equals 0. X minus 7 equals 0. Add 7 divided by 3. So we get x equals 7 over 3. And then over here we get x equals 7. So we get two values that satisfy Rowley's theorem. 7 divided by 3 and 7. Oh yeah, we don't use the endpoint, sorry. It has to be in the interior. Let me make sure we go back and show that. Sorry about that. We get the two answers, but you got to check them both. Go back. Okay, yeah, Rowley's theorem. So we're continuous closed. There's at least one point C in A, B, open interval. So because, because of the 7 being on the exterior, it's not on the open interval inside, we wouldn't use the 7. So just the 3/7.